Good morning everyone. In this lecture we are going to discuss about network programmability in software defined network for the 6th sem students, and this video is by Megha Garg for Women Engineering College, Ajmer. So let us discuss the issues with internet architecture. They are the complexity of network control and management, which includes the layered architecture, which is both a blessing and a curse, and the redundant and contradicting functions at different levels. The second issue is the complexity of changing network control, that is, the introduction of new protocols is becoming difficult. The next is the complexity of creating new services, that is, the mapping service requirements for vertically integrated devices is very difficult, and it is difficult to work around with overlays and L4 networks. So let us come with the network programmability. Network programmability is the ability to dynamically introduce a new architecture, protocols and services on top of a networking infrastructure which is existing, and it is customizing the treatments for a group of packets. That is, we assign a special meaning and new semantics to a pieces of packet headers. Network programming has been a new topic in the last 20 years. Network programmability is all about restructuring the main blocks and functions. That is, it is decided where to place the control intelligence, and it is all about balancing between basic forwarding and in-network processing. So this is your control, forwarding and in-network processing. Then we have to design the interfaces between the architectural components. For this, the programming needs to be done. We have to select the components that should be open to programming. So what all components can you really program inside the network? Not everything can be programmed. So first you have to decide what can you program. So what can you program is programming interfaces that you can do programming for. The next thing is programming levels. You have to decide up to what level programming can be done. How deep you can program, or like how narrow you can go, and the depth to which you program can impact the performance of the system. So you have to be fast when you program, like your program should run fast, it should be able to handle some kind of errors, and at the same time do the desired functionality, should cover all the features which you desire that your program should be running. So who should take the control? Now, who should take the control includes either it can be the one who's selling your equipments like routers, etc., or the other one who's purchasing can also decide that he or she himself decides to code. The important factors in this network programmability include the flexibility, scalability, like your code should work for 50 devices, for 500, for 5000, that is scalability. It should be secure so that it does not fall in the wrong hands, and openness should be there, open to the new standards of industry that are coming up. Cost, when it comes to cost, that the cost should not be too high. So for network programmability there are some approaches. These approaches were initiated in the 90s or 2000s, and these approaches are active networks. Like active networks were initiated in 90s. MPLS was initiated in the 90s, and it is deployed in production networks. Forces was initiated in 2000s, and SDN, which is a main subject, that was also initiated in 2000 by the academia and partially deployed in production networks. Then evaluation framework tells us which part is programmed. Like we already know which is forwarding plane, which is control plane, both can be programmed. What is the level of programmability? The level of programmability is packet, flow and class. Who takes the control over programmability? Network operator, service provider and the end user. We have to separate the control and forwarding plane, logical versus physical separation, and we have to discuss the availability and extent of in-network processing. So we'll see that in the next lecture.